International 540 hydraulic system. This program covers the hydraulic system used on the 540 wheel loader. It will cover the steering system as well as the loader system. The program is divided into two sections. The first section will show the location of the hydraulic components and explain how they operate. The second section will cover hydraulic problem diagnosis for this machine. Let's first take a look at how the steering system works. Shown here is a simplified schematic of the steering system. An ISO schematic listing flows and pressures can be found at the back of the training guide. Oil from the reservoir flows to the steering pump and the switch pump. The steering pump provides oil flow to the steering control valve. The switch pump output is directed to either the steering control valve or to the loader system, depending on engine speed. At lower engine speeds, the output from the switch pump combines with the output from the steering pump to supply the steering control valve. When the engine speed is increased, the flow from the switch pump is directed to the loader system. This shifting is accomplished by the diverter valve, which is located between the two pumps. The steering control valve directs oil to the two steering cylinders. The head side of each cylinder is hydraulically connected to the rod side of the other cylinder. This provides equal force in both directions. The return oil from the control valve passes through an orifice block. This block restricts the flow to the reservoir, forcing some of the oil to pass through the cooler. We'll now take a closer look at the components which make up the steering system. The hydraulic reservoir is located directly behind the operator's compartment. Located on the top of the reservoir is the lockable filler cap and vacuum pressure relief valve. This valve limits pressure in the reservoir to 30 psi and limits the vacuum to 0.3 psi. The refill capacity of the reservoir is approximately 35 gallons. Let's take a look at the inside of the reservoir. The top cover plate must be removed to service the filter. The filter is sealed at the top by the cover plate and at the bottom by the header. All oil returning from the loader control valve enters at the center of this header. Also, attached to the header is a surge valve, which protects the filter from excessive pressure. The reservoir is also equipped with a strainer located over each of the pump inlet ports. The strainers protect the hydraulic system from foreign material that may enter when servicing the filter. The gear-type steering switch pump has two elements and is driven off the torque converter. The front element, which is at the drive end of the pump, supplies only the steering control valve. Therefore, we'll call it the steering pump. The output of the rear element is used to supply the steering control valve at low engine speeds and the loader control valve at higher speeds. For this reason, we'll call it the switch pump. The diverter valve, which is located between the two elements, will shift the switch pump flow. The pump has two supply lines from the reservoir. The steering pump is supplied from the line connected at the diverter valve, and the switch pump inlet is on the switch pump itself. The outlet on the diverter valve is for the loader system, and the outlet on the steering pump is for the steering control valve. Let's take a look at how the diverter valve works. This valve is sensitive to switch pump flow. The diverter valve operates in two positions. The position shown here at low engine speeds provides the steering system with flow from the switch pump. The front element of the pump flows directly to the steering circuit at all times and does not flow through the diverter valve. The flow from the rear element enters from an internal passage in the housing. It flows through the orifice and around the spool, opens the check valve, and combines with the front element flow. As flow increases due to RPM increase, pressure will build on the inlet side of the orifice. This pressure will be felt through an internal passage at the left side of the valve. This pressure will be steering pressure plus the pressure caused by the orifice. Steering pressure only will be felt on the right side of the spool through another internal passage. The spool has equal areas. Therefore, the spool will shift when sufficient pressure is built up on the left side of the spool to overcome the spring and steering pressure at the right side of the spool. This should occur between 1400 to 1600 RPM. When engine speed has reached 1600 RPM, the diverter valve spool should be shifted as shown in the illustration. The spool will shift the switch pump flow from the steering circuit to the loader circuit. The check valve will then seat and prevent backflow into the diverter valve from the steering pump. The orifice will always maintain the pressure differential across the valve. When the spool is in the position shown, the pressure on the left side of the spool will be loader circuit pressure plus the pressure caused by the orifice. The function of the piston in the diverter is to smooth the movement of the spool. As the pressure builds on the switch pump side, the piston will move and allow some of the oil to pass around it, which slows down the buildup of pressure. The shifting of the spool should occur over a 200 engine RPM range. Let's take a minute to review the first part of the program. Stop the tape while you're answering the questions. The answer to number 1 is false. The filter is located in the reservoir, but it is not under the filler cap. Number 2 is false. The diverter valve shifts the switch pump flow, not the steering pump flow. Number 3 is true. Switch pump flow is directed to the steering system, not the loader system at low engine speeds. The steering control valve is located on the right side of the rear frame, just below the operator's compartment. The function of the valve is to direct oil flow to and from the steering cylinders, which turns the machine. To turn the machine to the right, the spool is pulled out of the valve. As the machine turns, the linkage will push the spool back into the neutral position. The linkage will also return the spool to the neutral position when making a left turn. The steering valve is shown here removed from the machine. 2 circuit relief valves are housed in the steering valve. A circuit relief valve is located under the plug on either side of the steering valve. A system relief valve is located to the side of the control spool. The control spool is connected to the linkage. Oil enters the valve at the center port. Above the inlet port are the 2 cylinder ports. The reservoir return port is on the bottom of the valve. Let's take a look at the inside of the steering valve to see how it works. This drawing has been changed somewhat to simplify the illustration. Oil from the pump enters the valve at the center of the control spool. The oil will flow around the spool and out the return passage back to the reservoir. The oil flow between the pump and steering cylinders is blocked by the circuit relief valves. We'll now take a look at what happens when making a turn. The control spool has been shifted out of the neutral position, which would turn the machine to the right. The control spool blocks the flow of pump oil back to the reservoir return passage. With the flow of oil restricted, the pressure will increase at the inlet. The pressure increase will also be channeled through a cord passage to the check valve. The increase in pressure will open the check valve and pressurize the oil on the right side of the locking spool, shifting it to the left. The pressure at the inlet is felt in the right side passage to the circuit relief valve. This oil will move the right circuit relief valve poppet against the smaller spring and flow to the steering cylinder. After the locking spool has shifted, the return oil will open the check valve in the locking spool and flow back to the reservoir. Shown here are the circuit relief valves. The pressure acting upon the right relief valve is above the 3,500 psi setting. The pressure has moved the ball check and compressed the larger spring. This allows the excess oil to flow out of the cylinders into the return passage. This will cause the pressure in the return passage to increase. The opposite side of the cylinders, which are connected to the left circuit relief valve, will be under a very low pressure. The pressure differential across the left relief valve will be sufficient to move the poppet to the right and compress the smaller light spring. Oil will enter the cylinders and prevent cavitation. The circuit relief valves are preset and cannot be adjusted. Oil entering the steering valve inlet port flows around the control spool and is always open to the main flow passage of the system relief valve. The top illustration shows the valve with system pressure below the relief setting, and the bottom illustration shows the valve with it above the relief setting. The oil enters at the center of the valve and flows around the main poppet. A small hole allows the pressure to be felt inside of the main poppet and on the face of the pilot poppet. When system pressure reaches the relief setting, the pilot poppet will move to the left and allow some of the oil from inside the poppet to enter the return passage. The pressure inside of the main poppet will be less than main pressure, as more oil will pass through the pilot poppet than can pass through the orifice in the main poppet. The pressure differential across the main poppet will move the main poppet to the left. The oil will then move the spool to the right and flow to the return. When the main pressure has dropped below the relief setting, the pilot poppet spring will seat the pilot poppet and the pressure will build inside of the main poppet. The main poppet spring will then seat the main poppet, which closes off flow to the return port. The pressure setting of the system relief valve is adjustable. An adjusting screw located under a cover can be turned in to increase the tension on the pilot poppet spring, which increases the pressure setting. Turning the screw out decreases the pressure setting. Part of the return flow from the steering control valve is sent to the oil cooler, and the rest is directed back to the reservoir. The flow is divided by the orifice block. This block has an open port to the oil cooler and a restricted port to the reservoir. The hydraulic oil cooler is mounted in the bottom radiator tank. From the cooler, the oil is returned to the reservoir. We'll now pause for a review of the steering control valve. Stop the tape while you are answering the questions. The answer to number 1 is true. The linkage is designed to return the control spool to neutral as the machine turns. Number 2 is false. The circuit relief valves block the pump flow from the steering cylinders. Number 3 is true. The circuit relief valves are not adjustable. Number 4 is false. The system relief valve is adjusted by changing the tension on the pilot poppet spring. And number 5 is false. Part of the return flow is sent to the oil cooler. Shown here is a simplified schematic of the loader hydraulic system. Oil from the reservoir is used to supply the loader pump and the switch pump. At lower engine speeds, only the loader pump supplies oil flow to the main control valve. As the engine speed increases, the flow from the switch pump combines with the flow from the loader pump. The main control valve directs oil to the bucket cylinder and the boom cylinders as required. In the next few frames, we'll take a look at each of these components. Let's start with the loader pump, since the reservoir has already been shown in the steering system. The loader pump is a single-element gear-type pump which is driven off the torque converter. This pump provides oil flow to the main control valve whenever the engine is running. The pump is rated at 44 GPM at 2,500 engine RPM. The oil flow from the loader pump and from the switch pump is combined in the manifold block before entering the main control valve. The manifold block is located below the operator's compartment. The main control valve is located under the operator's compartment, mounted to the right side of the front frame. This view of the valve is from the center hinge area looking forward into the front frame. The main control valve contains two spools, one for the operation of the bucket and the other for the operation of the boom. Each spool is equipped with a detent and air-activated kick-out assembly. This view also shows the location of one of the bucket circuit relief valves and the boom anti-void valve. Oil from the pump enters at the left side of the valve and returns at the manifold, which is mounted on top of the valve. This view is of the bottom of the main control valve. The system relief valve is mounted to the front side of the valve. A quick disconnect is provided on the valve to check the system relief setting. The 4 cylinder ports are located on the bottom of the valve. The 2 ports closest to the system relief valve are for the bucket cylinder, and the other 2 are for the boom cylinders. Let's take a look at how the components of this main control valve work, starting with the relief valves. There are 3 relief valves used on the control valve. There is the system relief valve and 2 relief valves for the bucket circuit. All 3 valves are of the same design but have different settings. The valves not only limit the pressure, but also prevent cavitation. The illustration at the left shows the operation of the relief anti-cavitation valve at operating pressures. Oil at line pressure is admitted to the inside of the valve through the hole in the center of the piston. Since the oil has a larger area to work against at the top of the main poppet and piston than at the bottom, a greater force is exerted on the top of the poppet and piston. This downward force keeps the main poppet and piston tightly seated. The illustration at the right shows the operation of the valve when relief pressure is reached. The line pressure oil unseats the pilot poppet, flows out of the cross-drilled holes and down the outside of the cavitation poppet to the return passage. With the pilot poppet actuated, pressure on the top of the piston is reduced. Line pressure causes the piston to move up and seat against the pilot poppet. This blocks further oil flow to the area above the main poppet. With low pressure on the top and line pressure on the bottom, the main poppet unseats and directs line oil to the return passage, relieving any excess pressure. With the piston backed up to the pilot poppet, the effective working area of the poppet is increased, since, in this position, it includes the lower face of the piston as well. This added working area will cause the pilot poppet to hold open until the pressure drops about 100 psi lower than the cracking pressure. This open to close pressure range prevents chattering and reduces the workload on the poppet and other valve components. Let's take a look at the anti-cavitation operation of the relief valve. The illustration at the left once again shows the operation of the relief anti-cavitation valve at operating pressures. Line pressure is felt in the valve through the hole in the center of the piston, keeping the piston and main poppet seated. Return pressure oil passes through holes drilled in the cavitation poppet. It flows around the beveled area of the main poppet as it flows through the return passage to the reservoir. When return oil moves through the valve, it exerts pressure against the beveled area of the main poppet and cavitation poppet. The return oil passage is kept under pressure by the reservoir pressure relief valve. The illustration at the right shows what happens in the valve to prevent cavitation when line pressure oil in the cylinder passage drops below the pressure of the oil in the return passage. When line pressure drops, the pressure above the main poppet also drops. At this condition, the pressure of the return oil working on the 2 beveled areas can overcome the force of the spring above the piston, unseating the cavitation poppet and the main poppet. With the cavitation poppet unseated, return pressure oil is able to fill the void in the cylinder line passage. The relief pressure setting can be changed by adjusting the tension on the pilot poppet spring. The anti-cavitation valve has no provision for adjustment. This program continues on tape 2.